Now the next question is, show that the sequence Sn, which is 1 plus 1 by n to the power n, is convergent, and then we need to prove that this limit, it lies between 2 and 3. Now using binomial expansion, we can write Sn as 1 plus n into 1 by n minus 1 upon factorial 2, 1 upon n square, and n minus 1, n minus 2 upon factorial 3, 1 upon n cube. Now here n and n will cancel. So we can write this Sn as 2 plus 1 upon factorial 2, 1 minus 1 by n plus 1 upon factorial 3, 1 minus 1 by n, 1 minus 2 by n, and then the sequence continues. Now this sequence, it is an increasing function of n. So this sequence is an increasing sequence. And since this is 2 plus some positive value, we can say that this Sn, it will always be greater than 2. Now we need to prove that it is less than 3. Now what we'll do is, we'll write as n tends to infinite, this 1 upon factorial 2, it will be less than or equal to 1 by 2. This 1 upon factorial 3, it will be less than 1 upon 2 square. Next one will be less than 1 upon 2 cube. So from this we can write this Sn will be less than 2 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube up to infinite. This is nothing but an infinite GP. We can write this as 2 plus a upon 1 minus r, which is 3. So from these two conditions, we can say that the sequence is bounded and its value will lie between 2 and 3. So the sequence is monotone increasing and it is bounded. That means this sequence, it is a convergent sequence, and the limit of the sequence will lie between 2 and 3. We can find the limit of the sequence also. We can write this limit as limit n tends to infinite Sn, and it will be this limit n tends to infinite 1 plus 1 by n to the power n. Now we can write this as limit n tends to infinite e to the power log 1 plus 1 by n to the power n, which we can write as e to the power this limit n tends to infinite log 1 plus 1 by n upon 1 by n. Now this is standard limit, log 1 plus x upon x, which is 1. So the limit point of the sequence is e, whose value is 2.7 something, which lies between 2 and 3.